Hello everyone, welcome you all to this discussion. Hope all of you are doing well in your life. So let's begin today's discussion without much delay, and let's start with a famous quote by Swami Vivekananda. He once said, "Arise, awake, and stop not till the goal is reached." So, what is the goal of the student? The goal of the student is he can turn a nation situation, he can turn a underdeveloped nation into a developed nation through the command on education, because it is the education through which he can transform the nation. So let's begin today's class. Today's discussion is on chemical reaction and equation. Chemical reaction and equation. What is the agenda of the class or discussion? First, we will discuss about chemical reactions and its examples. Second, we will discuss about chemical equation and example. Third, we will discuss about stoichiometric coefficient. Fourth, we will discuss about balanced and non-balanced equation. And fifth, we will discuss about how one can balance and equation of chemical reaction. So we will learn all of this in today's discussion. So let's start for first agenda, that is chemical reaction and its examples. Let's take some daily life examples. First example is charcoal burning. Charcoal burning. Burning of charcoal or charcoal burning. Second, rusting of iron rod. Third example is ripening of fruits. Ripening of edible fruits. जो फल हम लोग खाते हैं उसका पक जाना. And fourth thing is burning of natural gas. Natural gas. All these are the real life examples of chemical changes, and in all of these chemical reactions occur. In charcoal burning there is a chemical reaction. In rusting of iron rod there is a chemical reaction. In ripening of edible fruits there is a chemical reaction. In burning of natural gas there is a chemical reaction. So we can't see the direct chemical reaction in all these examples, but scientists have studied it and have derived the chemical examples or the chemical reactions which are occurring all of these processes. So let's take some chemical aspect of the chemical reaction. Let's say burning of natural gas. Natural gas. So the main element of the natural gas is methane. Its chemical formula is CH4, 1 carbon and 4 hydrogen. And burning means reaction with oxygen. Reaction with oxygen. Now, what is the chemical reaction? If we represent it, CH4 plus oxygen, it will give carbon dioxide and water. So this is a chemical reaction which occurs when burning of natural gas is processing. So this chemical reaction takes place in burning of natural gas. So it's a chemical change in which this reaction is occurring. So this is a chemical reaction. It is a chemical reaction. We have already told that chemical reactions are the process which is occurring in a daily life example, that is burning of natural gas. So now we will discuss about what is chemical equation and what is chemical reaction. Chemical equation is nothing but the representation of chemical reaction. If one say that natural gas, the burning of natural gas, it is a chemical reaction, but how can we represent the burning of natural gas in pen and paper? So with the help of the chemical equation, we can represent the chemical reaction in pen and paper and show the data to the public. So it is nothing but the representation of the chemical reaction. So what is chemical reaction? Chemical reaction is let's say charcoal burning. It's chemical reaction. Now how one can represent it? Charcoal burning can be represented as chemical equation, which is charcoal means carbon and burning means reaction with oxygen. It will give carbon dioxide. So this is chemical equation. This is equation. The representation of the chemical reaction is called chemical equation. So let's see the various examples of chemical equation. First, charcoal burning, C plus O2 equal to CO2. This is the chemical equation. Second equation is hydrolysis of hydrogen plus oxygen who will give water. Third, the burning of natural gas, methane plus oxygen, it will give carbon dioxide and water. All these are chemical equation. Chemical equation which represents the chemical reaction. Now, in chemical equation and chemical reaction, there are mainly two pillars. The first pillar is reactant and second pillar is products. First pillar is reactant and second pillar is product. So how can we identify what are the reactants and what are the products? In a chemical equation, all the initial substances that undergoes chemical reaction are called reactants, which often abbreviated as left hand side. And after the reaction, the final substances or the later on substances are called products, which are called right hand side. So the substances which is undergo chemical changes is called reactants or left hand side, and the final substances after the reaction is called product. And the reactant or product are, they are different in nature, both in physical and in chemical form. Their physical properties and chemical properties are very, very different from each other. Now, why this term left hand side and right hand side? And what is the significance of this arrow? The significance of this arrow, is it signifies the direction of the reaction. Direction of the reaction. That's why we told that it is reactant and it is product. The direction is from left hand side to right hand side, from left side to right side. That is why it is called left hand side and it is called right hand side substances. Because if we stand here and just look towards this perpendicular to this arrow, it will be my left hand and it will be my right hand. So this, all the substances that are left hand side are called right hand side products, and all the substances which are left to the arrow is called left hand side products. Left hand side substances. So we discussed about what is chemical reaction. Chemical reaction is nothing but there are a relationship between reactants and products. And what is the representation of the chemical reaction? Chemical reaction representation is called chemical equation. Now, what is reactants and what is product? We will see the substances which are undergo the chemical reaction is called reactants, and the final substances are called the products. This is called left hand side substances, it is called right hand side substances. It is initial, it is final. And the arrow signifies the direction of the reaction. And the reactants and the products are very much different, both their physical and in their chemical aspect. So just a gist what we have studied till now. First, we talked about chemical reaction, which is nothing but reactants and products. Second, chemical equation. Third, reactants and products. And fourth, direction of reaction. So till now we have studied all of this. Now let's move forward towards let's take an example. CH4 plus oxygen, it will give carbon dioxide and water. So when you write chemical equation often abbreviated as CE, chemical equation, it has two aspects. First thing is, must write all the exact chemical formulas of elements. And second thing is, use stoichiometric coefficient to balance the number of atoms in each element on both sides. Both side means left hand side and right hand side. So when we write a chemical equation, first keep it in your mind that must write all the exact chemical formulas. What is chemical formulas? Like carbon dioxide is chemical formula is CO2, magnesium oxide chemical formula is MgO, chemical formula of water is H2O, chemical formula is carbon monoxide is CO. These are called the exact chemical formulas. And now come to the stoichiometric coefficient. Let's take or let's illustrate with examples this stoichiometric coefficient. Take an example: hydrogen plus oxygen, it will give water. In this reaction, this is the chemical formula of hydrogen. This is the chemical formula of oxygen, and this is chemical formula of water. So first criteria is done. Hydrogen, oxygen and water, and their chemical formula is exact. So it is done. First term and condition is done. Second thing is stoichiometric coefficient. Stoichiometric coefficient. Why we use stoichiometric coefficient? To balance the number of atoms on both sides. Here the number of hydrogen atom is 2. Number of oxygen atom is 2. So number of hydrogen atom is 2, number of oxygen atom is 2. But in the right hand side, the number of hydrogen atom is 2, but the number of oxygen atom is 1. We should consider the individual atom of each element. The element of hydrogen, number of atom is 2. Here this is 2. The number of oxygen atom is 2, but in the product the number of hydrogen atom is 2 and the oxygen atom is 1. So it is not suitable to apply stoichiometric coefficient, or stoichiometric coefficient is not satisfied here. So what should we do? We use stoichiometric coefficient like this. If we write this chemical equation like this, H2 plus O2 equal to H2O, and put 2 here and 2 here, and then the number of hydrogen atom is here is 4, oxygen 2, here hydrogen 4, oxygen 2. What is 2 H2O? It simply means 2 multiply H2O. It's hidden, but it simply means 2 into H2O. Here also 2 into H2. And whenever there is nothing, just assume 1 into H2. So here oxygen atom is 2, hydrogen atom is 4. In the product, it is hydrogen atom is 4, oxygen atom is 2. So it is the number of atoms on both sides, left hand side and right hand side is equal. So stoichiometric coefficient is applied here. What is stoichiometric coefficient? This 2 is stoichiometric coefficient. This 2 is stoichiometric coefficient, and this 1 is called stoichiometric coefficient. So stoichiometric coefficient is 2, here 2 and here 1. So this example is not stoichiometric coefficient satisfied here, but stoichiometric coefficient satisfied here, because the number of atoms in each element is equal both in left hand side and both in right hand side. And here just take another example. Let's take the previous example. H2 plus O2 equal to H2O. This is first and this is second. 2H2 plus O2 2H2O. Here numbers are number of atoms of each element is equal on both sides. Here not equal. If the number of atoms is not equal on both sides, this reaction is called non-balanced chemical equation. And if the number of atoms on both sides is equal, then this reaction is called balanced chemical equation. So when the number of atoms on each element is equal on both sides, it is balanced chemical equation, and when the number is not equal on both sides, it is non-balanced chemical equation. Often examiner will ask you how one can convert the non-balanced chemical equation into a balanced chemical equation. Here I should tell you one thing that is common, that is the concept of mass conservation. Mass conservation. Let's take an example to understand the mass conservation. Here let's take the example number 1. Here the atomic mass of this hydrogen is 2 and this oxygen is 32. How? 16 into 2, because 16 is atomic mass of one oxygen atom. Here 2 oxygen atom, so that is equal to 32, and 2 into 1, because 1 is the atomic mass of one hydrogen atom. Here 2 hydrogen atom is present, so it is 2. Now the molecular mass of water is here 2 plus 16, that is 18. Now what is the conservation of mass concept? The conservation of mass said that mass cannot be created or not destroyed. But in case of chemical equation, mass conservation means total mass of reactant is equal to total mass of the product. Now see, total mass of the reactant is the total mass of the product. Now here what is the total mass? 32 plus 2, 34 total mass. It is total mass. And here is 18 total mass, which is not equal. So this reaction is also called non-balanced chemical equation from mass conservation point of view. One, I already told you the stoichiometric coefficient, and second thing is mass conservation concept. So mass conservation is not applying here. It is not satisfying the mass conservation law. The total mass of the reactant equal to total mass of the product. So it is unbalanced chemical equation. But if we apply the mass conservation rule here, in this reaction, let's see, 4 hydrogen atom, so 4 into 1 equal to 4, and oxygen is 32. and 2 into 18, that is 36. So if we add 4 plus 32 equal to 36. So total mass of the reactant, TMR, total mass of the reactant is equal to total mass of the product, TMP. It is 36, it is also 36. So mass conservation law is applied. Mass conservation law is applied here. In this reaction, it is unbalanced because mass conservation law is not applied. This equation is balanced because mass conservation is applied. It is balanced. So how we can tell you how one can tell the equation is balanced or unbalanced? First, count the number of atoms on each element. If it is equal, then it is balanced. If it is unequal, it is unbalanced. Second, consider the mass conservation law. If it is applied in this, if it is applied, then it is balanced. If it is not applied, then it is unbalanced. So based on the stoichiometric coefficient and mass conservation, one can decide which equation is balanced and which equation is not balanced. Now the examiner will ask you how we can convert a unbalanced chemical equation into a balanced chemical equation. A balanced chemical equation. How we can convert it? How? I will tell you two types. First type and second type. Let's take an example. How to balance a chemical equation. The examiner will give you an unbalanced chemical equation and ask you to balance it. How to balance? Let's take an unbalanced chemical equation. CH4 plus O2, it is oxygen, it is methane. Natural gas, it is oxygen. Both are there in chemical formulas which will give carbon dioxide and oxygen, carbon dioxide and water, which is carbon dioxide, and it is water. It is an unbalanced chemical equation because the hydrogen is 4 here, hydrogen is 2 here, so number is not equal on both sides. Second thing, oxygen is 2 here, oxygen is 3 here. Let's count carbon, hydrogen and oxygen, reactants and products. Number of carbon in the left hand side is 1, in right hand side it is 1, it is equal. But in hydrogen it is 4 and in here it is 2. It is not balanced. Oxygen it is 2, it is 3. So this equation is called unbalanced. Unbalanced equation. And you can also justify it is unbalanced based on the theory of mass conservation, and it is also an unbalanced equation. First method to balance this equation is called trial and error method. Trial and error. Trial and error method. First, we should look at the number of atoms of carbon and hydrogen. Carbon, hydrogen and oxygen. It is 1 in reactant and in product. It is 1, it is 4, it is 2 and it is 2, it is 3. So it is here in 4. So if we put 2, just put 2, that place 2 in your mind and take a rough sheet and do it. First step, just put trial and error method, putting the numeric numbers. First, CH4 plus O2 will give CO2 plus water. Hydrogen is 4, just put 2. Hydrogen will 4. Carbon is 1, so carbon is 1. So don't try to deviate the number of carbon. So carbon is 1 here, carbon is 1 here. So it is equal. Hydrogen is 4 here, hydrogen is 4 here. Now it is equal. So now turn to oxygen. CH4 plus O2 CO2 plus 2H2O. Just write down this step. And now count oxygen. It is 2 oxygen here, it is 2 oxygen here. Because it is 2 into H2O. So basically it is 2 oxygen is here. So 2 oxygen here and 2 oxygen is here. 2 oxygen here, 2 oxygen here. But the number of oxygen here is 2. So just multiply with 2. 2. So it will give 4 oxygen is here. 2 here, 2 here, 4 here. Carbon is 1. Carbon is here 1. Hydrogen is 4. Hydrogen is 4. Now the reaction is balanced because CH4 plus 2O2 will give CO2 plus 2H2O. This is the balanced chemical equation. And the process through which we could conclude that it is a trial and error method. Balanced chemical equation. Carbon 1, carbon 1. Hydrogen 4, hydrogen 4. Oxygen 4, here 2, here 2, 4. This is the balanced chemical equation. Now second type is but before going to the second type, I will tell you some examples. Just remember the form: metal, then non-metal, then oxygen, and then hydrogen. It is the balancing sequence. It is the balancing sequence. It is a balancing sequence. So which are the metals? Metals are sodium, potassium, zinc, aluminium, and many others. Non-metals are carbon, non-metals are chlorine, non-metals are sulfur, non-metals are phosphorus. Now it is turn of oxygen and then hydrogen. Oxygen and hydrogen are also non-metal, but in case of balancing the equation, we consider it as a separate thing. So just remember the sequence: metal, then non-metal, then oxygen, then hydrogen. First, we will balance the metal, then come to non-metal, then come to oxygen, then come to hydrogen. So this is the balancing sequence. Now take an example. First example: CH4 plus O2, CO2 plus H2O. So just check whether there is any metal present. So no metal is present. So metal part is finished. So now non-metal. Non-metal is carbon. Non-metal is carbon. Carbon. So the number of carbon is here is 1. The number of carbon here is also 1. So don't try to deviate the number because it is equal in both sides. So just let it go. Now come to oxygen. Oxygen it is 2 here. Oxygen it is 1 here. Total is 2 plus 1 equal to 3. And here it is 2. And we have to balance it. And then come to hydrogen. Hydrogen here is 4 and then hydrogen here is 2. Now you should consider that 2 and 3 and 4 and 2, this is hydrogen number, this is oxygen number, this is oxygen number, this is hydrogen number. This 2 and this 4, the 4 is the multiply of 2, so we can easily put 2 here. After putting 2 here, we then reconsider the whole reaction, because 2 and 3 is quite difficult to equal, quite difficult to balance, but 2 and 4 it is quite easy to balance. So that's why we move towards the hydrogen. Simply putting 2 here, then reconsider the equation, that is CH4, carbon 1, hydrogen 4, but oxygen is still 2 and 2, here 2, 4, and there is 2. So just put 2. It is called the metal, non-metal, oxygen and hydrogen. Let's take another example. To more clarify it. When iron reacts with H2O, it will give Fe3O4 plus hydrogen. When iron reacts with water, it will give Fe3O4 and hydrogen. Now what is the metal here? Iron is the metal. Here it is 3, so just put 3 here. After metal, then come to the non-metal. What is non-metal? There is no non-metal. So then come to oxygen. What is the level of oxygen? It is 1. It is 1 here. And it is 4 here. So just put 4. After putting the oxygen, count the number of metals and oxygen. Here metal is 3. Here metal is 3. It is okay. Here oxygen is 4. Here oxygen is 4. It is okay. Now come to the hydrogen. The hydrogen is total is here 8 and here hydrogen is 2. So we can just simply put 4 here to balance the chemical equation. So it is quite easy to follow this sequence and to balance the chemical equation from a unbalanced one to a balanced one. So what we have studied till now, first we studied about the chemical reaction, the real life example of the chemical reaction, that is the ripening of the fruits, rusting of iron rod, card formation from the milk. Why I am giving the real life example? Because in real life example the student can connect the study with the real life, so they can digest the understanding of the subject with very easily and present them in the exam. So that is why I am giving the real life examples. So chemical reaction first, what we have studied till now is chemical reactions and their examples. Chemical reactions and their example first. Second, we have studied the chemical equation and their examples. Third, we will discuss about the reactant and the products. Fourth, we have discussed about the balanced equation, balanced and unbalanced chemical equation, unbalanced chemical equation, how we can differentiate balanced and unbalanced by using stoichiometric method and mass conservation method. And sixth, we have discussed about how to balance a chemical equation. So after finishing the discussion, I would like to tell one more important thing. That is, whenever you write a chemical example or chemical equation, please write balanced chemical equation. Balanced chemical equation. And use the physical states of each element that take part in the reaction. Now, what is the physical state of each element? In chemistry, there are 4 types of physical state. First is solid physical state, which we can abbreviate it as S. Liquid physical state, which can be used L. Aqueous physical state, aqueous state which can be used or which can be symbolized as AQ, and gaseous physical state which can be denoted by G. So solid physical state, that is S, liquid physical state we use L, aqueous physical state we use AQ, and gaseous physical state, that is AG. Just look at example. So while writing a chemical equation, always use balanced chemical equation, and second thing is physical state should be mentioned there. How? Let's take an example. Addition of water in quicklime. Quicklime is calcium oxide. Chemical formula is CaO. So what is the chemical equation? Chemical equation is CaO. Now specify its physical state, that is solid, plus water which is liquid form, which will give you calcium hydroxide which is in aqueous form. So calcium oxide, it is solid, water, it is liquid, and calcium hydroxide, it is aqueous form. Liquid means only water is present here. Aqueous means this substance is present with water. This product is present with water, which is called aqueous. It is present with water, and liquid means only water is present, no other element is present. Let's take another example. Like burning of charcoal. Carbon, it is in solid state. Oxygen, which is gaseous state, which will give carbon dioxide, which will be in gaseous state. Now if you write the equation, it is balanced chemical equation, and all the elements are in their physical state. Second, like there is CH4 plus O2. Sorry, is CH4, which is also a gaseous form, O2, which is also a gaseous form, which will give CO2, which is also a gaseous form, and it is water, also a gaseous form. So now if you write down the equation, it is not a true one because it is not balanced. How to balance it? Write 2 here and write 2 here. Now it is the balanced chemical equation, and it is also the physical state are present. So water G means key. Water G means water vapor. Water vapor. Water L means pure water in liquid form. Pure water in liquid form. Water S means solid form, that is ice, and water G means water vapor. So we talked about chemical reactions and chemical equations. What are the chemical reaction? Give some of the real life examples, and then what are the reactants and products? What are the reactant and the product? What is left hand side, right hand side? What is the significance of the arrow? That is the direction of the reaction. Then we will we forward towards the chemical equation. What is the unbalanced chemical equation and what is the balanced chemical equation? How we can consider what is unbalanced and what is balanced through the stoichiometry method and the mass conservation method. What is mass conservation? Mass conservation is nothing but the total mass of the reactant is equal to the total mass of the product. And second, how one can balance the chemical equation? We use 2 formula, that is first of all trial and error method, and second thing is the balancing sequence, metal, then non-metal, then oxygen, then hydrogen, and last thing, use the physical states of the element and use the balanced chemical form to write down a chemical equation. Now, I would like to thank Unacademy for providing me such an opportunity to give a small discussion on a topic. Thank you.